So chapter 2, section 7, rates, ratios, proportions, they're similar. Want to first talk about ratios. A ratio, you've been doing this for years. They compare two quantities. So compare or compares two quantities. And quantities are really just kind of like numbers of things. So the common example, at least that I always end up using, is if you're talking about like a guy to girl ratio. Supposedly you can go on Wikipedia and find the guy to girl ratio for every college in the United States, which if you're going to college to find a girl or a guy, you could look to get odds in your favor. Okay, so if you were to do this, when you get something like this, when they write out a ratio, whether it be like owners to pets or guys to girls or teacher to student ratio, you can probably look that up online too. The first thing listed is always going to be the numerator. So the thing before the 2 is going to be the numerator, the top of the fraction. The thing afterwards is always going to be the denominator. So in other words, if you were talking the guy to girl ratio in our classroom, and without taking the time to count, we'll maybe just say it's 12 to 14, which totally isn't true. That'd be 26 of you. But okay, if it was 12 to 14, if you wanted to write that as a fraction, it would be 12 over 14. And then we probably should go and reduce that to 6 over 7. That'd be a little more proper to reduce it to 6/7. Does that make sense for ratios? Yes. So it's really just two quantities. Often they don't have units associated with them to officially be a ratio. The second thing I want to look at is going to be a proportion. And what a proportion does is it really just takes two ratios and makes them equal to each other. So I'm going to say proportion, then just a little dash, that they're equal ratios. And how proportions work is if you're trying to solve like a story problem or something like that, that you know the ratio of something, you can find a missing part. I probably should, before I jump into there, just say like, okay, examples would be like 3 over 4. If that's a certain ratio, a proportion, then is going to be this ratio, this fraction equals something else. So if I were to say my numerator of my second one is a 6, the denominator would have to be 8. Because 3/4 equals 6/8. They're both 0.75. Or you could reduce the 6/8 down to 3/4. Yes? That both fractions equal the same amount, they're the same number. So if you were to do something like the ratio of cats to dogs is 3 to 5. So ratio cats to dogs is 3 to 5. If 27 cats, how many dogs? So the ratio of cats to dogs is 3 to 5. If there's 27 cats, then how many dogs? When you get something like this where there's 4 numbers total, they give you 3 of the 4 you're solving for it, please set up a proportion. You don't need to write this, but kind of how we're going to do it, I'm just going to work through it together. I know some of you are like chomping at the bit to give the answer, but if you have cats to dogs, what we're really saying is we're saying, okay, cats to dogs, that ratio is going to equal the second ratio, cats to dogs. And so in other words, my first one right here I have, it's 3 to 5. We could, where it says 3 to 5, we could write that as 3 over 5. Agreed? And then we'd say 3 over 5 equals what over what, Franklin?
27 over x.
27 over x. Perfect. That we know there's 27 cats. So if you notice, the reason I wrote the 2 fractions there is just to show that cats always has to be in the numerator. That's probably one of the most common mistakes people will make, is they'll have the number of cats be in the numerator of one, and then they'll have the number of cats be in the denominator of the other. It's like you need to have the same quantity in the numerator both times. Is that fair? Okay. So 3 over 5 equals 27 over x. There's a couple ways to solve for that. One would be to do what? Go for it, Tyler.
I was just going to say 3 times what equals 27.
Okay. So 3 you could say times 9 gives you 27.
And then you do times 9 with the denominator.
So x has to be
45.
x has to be 45. In one like this, that's perhaps the fastest way to go through and do it. If you have something where you're getting some like really ugly numbers, your multiplier isn't something pretty, or maybe your answer x is going to be some ugly decimal, another way to solve that same problem would be to cross multiply and then divide. So if you wanted to, here's a second way I'll just do real fast. If we have this problem there, cross multiply and divide is kind of like that ichthus fish kind of thing. You do the numerator of one times the denominator of the other, so 3 times x equals the numerator of one times the denominator of the other. So 5 times 27. So 5 times 27 should be 135 if I did my math right. So 3x equals 135. If you want to get x by itself, you would, I think I heard it real quietly, divide by 3 from our quiz last week. So x is going to be 45. So that way it takes longer, but you might find that cross multiplying is nicer if you get some psychotic decimal answer, or you're looking at it and the multiplier doesn't pop into your head. The third thing, Roman numeral 3, is going to be a rate. A rate is going to be a ratio, but the units have to be different. So at the beginning, when we had like the guy to girl ratio, it was like a number of people over a number of people. You know, the units are the same. Here, a rate is going to be a ratio of two quantities, two numbers, but they have to have with different units. So a ratio of two quantities with different units. And the real common one we'll throw like a science one at you is they'll go with speed. That if you have speed as distance over time, d over t is going to be a rate because the units for distance can't be the same as the units for time. I'm going to go 1 mile for a distance. In my time, it's going to take me 1/10 of an hour. So for the one, I have units of miles. The other one, I have units of hours. The units can't cancel out. Where if you have a ratio where the units are the same, the units will cancel. So 1 divided by 1/10 equals 10. Because 1 divided by 1/10 is the same as 1 times 10 over 1. Remember, dividing by a fraction is the same as multiplying by the reciprocal. And the units are going to be 10 miles per hour. Because the units don't cancel, you can just take your original problem and look at whatever the units are there. This is the thing you have to pay attention to, or you're going to pay. And this is the thing that's going to come back over and over and over into high school science. So dimensional analysis. Often you don't see it using this unit, but the way that they were teaching chemistry at my old high school, it's totally just this problem over and over and over for a bunch of different things. Basically, what is it? We're just going to take and multiply a bunch of fractions together to convert from one unit to another unit. So I'm going to say it's multiplying, so that's mult fractions to change the units to what you want. And this is going to be the thing that's probably the most confusing in the section. Say, for example, I want to convert 4 miles into feet. Well, I could say 4 miles. I'm going to put 4 miles over 1. And there's just 4 over 1 is 4. Miles over 1 is just miles. But now if I want to convert this to feet, I need to somehow change that miles into feet. Well, I could take a fraction. As long as I multiply it by 1, I don't change the value of the fraction any. But in order to multiply it by 1, I'm going to do this. I could, since 5,280 feet, I wouldn't write this yet, but 5,280 feet is the same as 1 mile. Those two distances are exactly the same, so essentially that's really just 1. Or 1 mile over 5,280 feet, that also is 1, because those two distances are the same. Well, if I want to take one of those and put it up above to multiply, if I were to do the second one and put it in there, that's not going to work because I'll end up with a fraction where I'll have miles on the top. If I do my math, my units, I'm going to get miles times miles or a mile squared. That's not helpful. But if instead I take my first fraction and say 5,280 feet over 1 mile, the nice part about that now is my miles here cancels with my miles there, and the only units left in the problem would be feet. So 4 miles then would be the same as 4 times 5,280. That gives me 21,120 feet. And then if I take my denominator and do 1 times 1, that just gives me 1. So 21,120 feet over 1. But let's say instead of that, if I'm not trying to just go to miles, let's say I'm trying to go down to inches. To do that same way to start, you could say, all right, I have 4 miles over 1. I'm going to multiply that by 1 mile. I'm going to put that down on the bottom so my miles will cancel out. And then I could say, well, 5,280 feet is equivalent to 1 mile. So that'll get my units down to feet, but I want to get down to inches. So I could say, all right, if I put 1 foot right here, now I know my feet are going to cancel out just like my miles did. And I want to say, well, how many inches are going to be in 1 foot? And that'll be 12. So now I could do 4 times 5,280 times 12. So if I do my answer times 12, that now tells me it's going to be 253,440. And the only units that are left are going to be inches. So there's 253,440 inches in 4 miles. I'm going to say 70 miles per hour is how many meters per second. So I want to go from miles per hour to meters per second. So if I were to do 70 miles per hour, can I convince you that's the same as 70 miles over 1 hour?
Yeah.
Now the difference here compared to the other one is you're going to have to do some multiplying and some dividing. And you have units in the numerator and the denominator to start out with. Okay, miles to meters. Can anybody guess from miles to meters? Who's my track people? Mile run is also the... Oh, bummer. So do we do 1,600 meters over 1 mile? Or do we do 1 mile over 1,600 meters? First one. Because then our miles can cancel, right? We'll be able to cancel miles with miles. So 70 miles over 1 hour times 1,600 meters. Now if you look at the units that are left are meters divided by hours, or meters per hour. Agreed?
Yeah.
We want to get down to meters per second. So now we need to take hours and change hours to seconds, or at least get closer. To cancel out hours, do you agree I need to put hours on the top? Because now my hours will cancel.
Yeah.
Hours straight to seconds might be tough at your point, but we could go hours to minutes. How many minutes in an hour? Do you agree 60 minutes in an hour? So now we're left with meters per minute for units. So we just need to go minutes to seconds. Minutes has to go numerator or denominator? Numerator. And we just need a thing where we know a certain number of seconds in a certain number of minutes. So we could do 1 minute is 60 seconds. You could also do 2 minutes and 120 seconds, or 10 minutes and 600 seconds. You just need to have something where the number of seconds and the number of minutes are the same amount of time. Now for these, I'm just going to slide my screen over a little bit once I shrink it. Essentially, to multiply these things, you just make it all one ginormous fraction. So we have 70 times 1,600 times 1 times 1, 112,000. And to really do it right, I probably should throw the units on there. That's going to be my minutes canceled out. So it's that many meters. Divided by 1 times 60 times 60, so 3,600 seconds are my only units there. So last step then is to do that. The 112,000 divided by 3,600, and you get 31.1 repeating, and the units would be just those right there, the meters per second.
Why'd you do that last step?
Because you could just say 31.1 if you wanted to, but my calculator says 31.111111.
Where'd you get 3,600?
Okay. To get the 3,600, I did 1 times 1 times 60 times 60.
Oh, so I didn't
And that gives me this.
Because one was in the bottom.
Yeah, for the first example, it was all ones in the bottom, so you didn't have to do that step.